So, the following awesome presentation contains slides with flashing images and storytelling purposes. In any event, described may or may not be fictional. Hey, you must be new to this co-working space. Let me introduce myself in form of a musical. I'm just Ozzie, engineering skills X10. It is my life to write YAML again and again and again. People love it when I break out into song during their workday. You're welcome, everyone. But with my 10x ability, there's no we today. This is an Aussie co-working space. I work for Big Corp, and I have kind of a big deal. And I think you already knew that, right? I'm wondering, I went to KubeCon Japan last year, and this is the t-shirt, I'm still wearing it. Might be a bit smelly because I didn't wash it, but this is my lucky t-shirt. We haven't had any security incidents since I'm wearing this, because this brings me luck. That's not the smell you're smelling? Oh, it must be my lunch. I've been microwaving fish. I get many compliments here, like, Ozzie, you're microwaving fish again. That smell lasts for days. People love it. What's that? You're into Kubernetes too? Let me show you my cluster. It's the perfect cluster. I built it all by myself. So this is Ozzie's production cluster. We've got big corp workloads, production workloads running live, and frankly, it's flawless. It's peak platform engineering security. Listen and learn. So there's a private Kubernetes API, no public exposure. We have least privilege RBAC, and deployments can only happen via GitOps. Here, it's Argo CD. Regular users can't access the Kubernetes API at all. We have multi-factor authentication on all our Git repos, and there's a service mesh with MTLS securing pod-to-pod communication, and cluster admission control via Kyverno, and runtime security with Falco. And there is a CI/CD pipeline for building and testing images and artifacts. All this from a 2-day conference, a technical masterpiece. Everyone in this co-working space is so lucky to have me today. I'm the perfect engineer. You know what? I'll go talk to management. I deserve a promotion. You wait here. I'm going to talk on the phone very loudly so everyone knows how important I am. Do you mind?
Oh, excuse me. Hello, I'm Nova. I'm here in this co-working space today too, and I'm so sick of that Aussie guy walking around here like he owns the place. He needs to be brought down to earth, am I right? And I think I'm the one to do the job. You see, I look pretty friendly, and I really am deeply kind. Like I buy my friends lavish birthday gifts with all the money I make stealing from people and their companies in co-working spaces like this. So people really should be more careful. So basically, I just hang out here, I pretend to work, and I watch people. And I look for someone who gets a bit excited and walks away with their computer unlocked. So I have this tool called a rubber ducky. Let me put this mic down. I have this tool called a rubber ducky. It looks like an innocent USB flash drive, but to the computer, it's a keyboard typing at superhuman speeds. So I'm going to plug it into Ozzie's computer and cause some trouble. I'll tell you more about exactly what that rubber ducky is doing later, but meanwhile, let's do something to mess with them in the short term. I'm going to use Ozzie's credentials to commit a YAML change on one of Ozzie's big corp deployments, so to run my container image instead of whatever was being run before. I'm sure it wasn't important. Oh, look at that. My change to the deployment triggered a deployment pipeline, but in the end, Argo CD pulled the change and ran my workload without question. Looks like Ozzie isn't as awesome as he thinks he is. Oh, this is a good sign. It's going to be a fun day. So now I'm going to lock his computer. Oh my God, look at this guy's lock screen. He's something else. Oh God, I have to get back to my desk before anyone sees me.
So management said they're going to call me back later. They're busy right now. Nova rules, Ozzie drools. First of all, that's not true. The pillow was already wet when I went to sleep. And why is that URL pointing at Big Corp? Oh no, Nova has somehow accessed my hardened cluster. I know Nova, or know of them. Some fool got pwned by Nova the other day. It was talk of the co-working space. Apparently, Nova got pictures of them, and they transferred Bitcoin money to Nova's wallet, and Nova is still asking for more. There was an investigation to find out who Nova is, but no one found anyone wearing a dark hoodie or a mask. I have to hurry up and delete this before anyone sees it. So, looks like Nova managed to deploy a workload to my cluster, but how? What changed recently? Let me look at the cluster events. Oh, this Big Corp deployment is running a different workload, a container named Ozzie Drool's latest. Nova! First things first, let's modify this deployment and revert back to correct image. Great, back to normal. Oh, I guess this is why people sign and verify images. So I need to use technology like Sigstore to sign my image as trusted, declaring it was built by Big Corp. And then I can make Kyverno policy that says an image can only be run unless it is verified that it is one of our Big Corp trusted images. Kyverno can use Sigstore to do the image verification. Booyah, I'm back, baby. I don't know why everyone is so scared of Nova. Ah, I know. They're not as awesome as me. There, now we're safe from the attack. And order is restored. I hope no one from Big Corp saw that.
I wonder what's going on over there. I've been watching my Big Corp website in my browser, and sadly, I can see he's taken it down. So remember I used that innocent-looking rubber ducky hot plug to interact with Ozzie's computer? Let me tell you what I did exactly. First, I made a copy of his kube config file, so now I know the IP address of that cluster he made and he won't stop talking about. I was also able to get Ozzie's private SSH key. Now I have his identity. I also got his SSH config file, so I know where Ozzie's private SSH key can be used. And I took the Git config files, which shows me all of the URLs to all of the Git repositories that Ozzie has contributed to lately. So now I can make Git commits as Ozzie. And this is how I was able to deploy that image earlier. And I intend to cause him much, much more trouble.
Nice. The CFO is calling me, probably about my promotion. How am I going to spend all that money? Maybe I go from microwaving fish to microwaving lobster. Ozzie speaking. Yes. Yes. No. No, what? A product that retails for $100 is now being sold for something around $15? We're losing money? That can't be right. I built this cluster myself. Okay, I'll fix this mess. Let me pull up the finance spreadsheet. So we're selling a $100 product for $13.37. That's a disaster. What kind of idiotic, rookie liability of a coworker of mine changed the price of our product? Let me check the recent Git commits. Wait, it was me? I didn't do that. What's this? A Docker file changed. Let me look at the Git diff. Oh, a new copy command. Right before the actual app gets built, this command copies a sketchy shell script. How did this get through my defenses? Big Corp's defenses. Nova must have changed this when she had access to the cluster. She's impersonating me. Let's see if this script is causing the pricing problems. I'll investigate.
Wait, what? Back to me already? Ozzie wishes. I'm running circles around that guy. Ozzie's about to notice that my Docker file modification isn't just a prank. It's been doing a lot more than changing prices. It's been quietly collecting customer data this whole time.
Wait a minute. This Docker modification is not just a prank. It's quietly collecting customer data this whole time? Oh crap. I underestimated Nova. And maybe I overestimated myself? Of course not, I'm awesome. Let's figure out how Nova pulled this off. Thinking about it, this Dockerfile itself has been inside the source code of BigCorp Git repo. So our build system picked it up, picked the malicious change up, and it built it like it would any other BigCorp image. And because the image was built by our official CI/CD pipeline, it was automatically signed and verified by our own systems. Sixdoor signed it, Kyverno let it through. It passed all my checks. Talk about egg on my face. This is embarrassing. I can now no longer show my face at the office. Thank goodness I work remotely.
So while Ozzie's been distracted with prank websites and his product prices changing, I've been doing my real money-making attacks. This whole time, the real hack has been running quietly in the background. That image that changed the prices, the one that Ozzie's hardened systems signed, verified, and deployed, it came with a bonus feature, a background data pipeline that's been streaming customer data info to me ever since it launched. And I'm going to sell that information for big money.
So first things first, I finally add git sign, so every commit to this cluster must be signed. There, Nova can't fake me again. I probably should have done that sooner. With git sign in place, only verified contributors can commit to our Git repos. Git sign uses keyless Sixdoor to sign Git commits with our own OIDC identity. But how do I stop an attacker from sneaking in malicious code via sources like Docker files? I guess this is why people talk about build provenance. We need to not just know who built the image, but how it was built, where it was built, and with what inputs. So this is why we need SALSA build attestations. SALSA stands for Supply Chain Levels of Software Artifacts. It is a security framework that helps ensure your software was built the way you think it was. SALSA is not just one thing. It is a set of security levels for protecting your processes, for building and sourcing the artifacts that run in your systems. SALSA build attestations can say things like, this image was built by GitHub Actions using BigCorp build scripts, or this image started from the right base image and not a sketchy image, or to prevent an attack like Nova's, to say this image was built using an approved and verified Docker file. So basically, SALSA build attestations can stop Nova from sneaking in fake stuff and tricking BigCorp into poisoning its own images. Let me see how to implement this.
Money, 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 money. Money. Wait, what? The information stopped making sense. Ah!
There we go. I just added Kyverno policy. Any image allowed into this cluster must have a valid SALSA build attestation that verifies the build follows trusted build steps, verifies the image was built from an approved based image, and verifies that it was built using an approved Docker file.
Ozzie must have figured out about SALSA build attestations and put another Kyverno policy in place, this time a SALSA build attestation policy. As much as I hate to admit it, I think Ozzie's getting better at supply chain security. But he better watch out. I'm not through with him yet.
Sweet mother of all that's good. We stopped the data pipeline. And look at that. Prices are back to $100. What a day. I'm glad that there will be no other problems with my cluster in the foreseeable future.
So back when I had access to Ozzie's cluster, I also saved a bunch of SBOMs. An SBOM is a software bill of materials, and each one lists everything that went into building a piece of software. So every tool, every library, every dependency. So I'm going to go through the SBOMs and grep for old-looking version numbers. Aha! Let's take a closer look at this first one, 0.9.2. A dependency called log4yay. Let's check out the GitHub page. Are you kidding me? One of BigCorp's most privileged services depends on a dusty old open source package? There's been no updates in like a year. Fork it. I'm going to fork it. You know how I mentioned earlier how nice I am? Well, I fixed some bugs in that dependency. I bumped the version number and published it. That's right. I'm helping. You're welcome, Ozzie.
Strange. Falco just sent me a runtime security alert. One of our internal services opened a connection to a weird external IP. Oh no, not again. Let me investigate.
Oh, did I forget to mention? I didn't just fix bugs in that version update. I also added a hidden backdoor that quietly opens a connection from Ozzie's cluster back to me. So guess what? I'm back inside BigCorp's cluster, and this time my code is buried inside a trusted dependency. And now I can use a little privilege escalation logic to upgrade my cluster access at any time I want.
Let's run a vulnerability scanner to see what's going on. Oh no, over 200 vulnerabilities? How am I supposed to know which ones are actually dangerous? Wait, OpenVex can help here. OpenVex can do 3 things: an open source specification, a library, and suite of tools. Using OpenVex, it helps me focus on security efforts on vulnerabilities that pose an immediate risk to my particular system. OpenVex eliminates noise by filtering out vulnerabilities that aren't exploitable on my particular environment. It knows how the software is actually used here in Ozzie's production cluster. Okay, so let me run this again using OpenVex. Wow, it narrowed down the long list of vulnerabilities to only one critical actual threat. Let me look at this more closely. Wait, Nova phones 1337? Wait, this is hacker term for lead, as in elite. Nova's making me look like a noob again. Nova, not again.
Shh, could you please keep it down?
You're always asking me to be quiet. Please stop making noise here. Please don't speak on a speakerphone. Please don't put Nickelback on your speakers. Your delicate ears. Why don't you mind your own business and work on your trivial work? Some of us have important things to do. Okay, so how did Nova best me again? I guess I really have to learn a lot from Nova. It is weird to say I actually kind of admire him. So researching Nova's package running in our cluster, looks like this dependency security update got approved without a second glance. It does seem super legit, but it fixes some bugs. But inside is a privilege escalation. So Nova was somehow able to attach this malicious code to that dependency, and now CI/CD picked it up and rebuilt the image. It signed it, it deployed it into production. BigCorp's pipeline just didn't stop it.
Did you all hear that? Did he just call my work trivial? Did he assume that because I'm good at coding that I must be male? Forget ransoming stolen data. I want Ozzie to pay. Let's use this backdoor. The backdoor gives me a shell into the app container, and then I'm going to use a tool called nsenter to break out of the container's Linux namespace and into the host namespace. Now I can run commands on the actual node and gain access to all of the machine as root, and now I can see everything on the entire machine. So I'm going to use this eBPF-based backdoor tool called BoopKit. It lets me manipulate the running system at the kernel level, which, as a side note, BoopKit was created by Chris Nova, a cloud-native security researcher, a wonderful human, and a friend. She inspired my name, but she used her hacking skills for good, not for evil like me. So right, I'm going to use BoopKit so that I can manipulate Ozzie's running kernel. Ozzie, this is personal. Let me show you what a trivial work your male antagonist is up to over here. I'm planting a fork bomb. A fork bomb is a tiny bash function that spawns itself recursively. It's actually the characters up there. It consumes all system resources and crashes the node. This is what you get for microwaving fish, Ozzie! Wait, what? It didn't work? Oh no, I lost access to the cluster? I didn't have enough time to set up my fork bomb. No! Oh! looks like I'm completely shut out. Dang it.
There. So who is the loud one in the office right now? Okay, so here's what happened. As you know, I used OpenVex and I found a suspicious package. So I looked into it and it was running elevated privileges. So it meant Nova could have escalated to root. So I contacted security at Big Corp and we pulled the plug. We created a new cluster and we quarantined the old cluster. So in our new cluster, to stop things from happening again, we added a software bill of material policy, SBOMs. From now on, we will track every component in our applications. Next time a dependency gets added or updated, we'll know. We will also require Salsa source attestations from open source dependencies using VSAs. VSAs, or verification summary attestations, are machine-readable files, prove every commit was reviewed and came from a verified contributor to an open source project. Then we added a Kyverno policy that says we will only allow dependencies that include valid, trustworthy source attestations. We can use forensics on the old cluster to figure out how far Nova got. And we now directed all customer traffic to the new cluster. This cluster is built now with everything that we put in place in the last 25 minutes. Best part is we have a brand new build process with hardened security.
Ooh, may I tell them about the security features of the new build processes?
Sure, but how do you know what I've been doing?
Don't worry about it. So first, I impersonated Ozzie and modified his Kubernetes deployment to add the Nova Rules Ozzie Drools website. To stop this, Ozzie used SigStore to sign and verify all images as trusted, or the ones built by Big Corp. And then he used Kyverno to make a policy that all images that run in the cluster must be signed and verified. Then I used Ozzie's credentials again, this time to modify a Docker file to run malicious code in addition to the usual code that's there. After that, Ozzie finally added git sign, so I couldn't commit it to him anymore. And he also made another Kyverno policy, this time requiring that all of the artifacts in the cluster, including Docker files, have Salsa build attestations. So now Big Corp knows not just who built the image, but how it was built, where it was built, and with what inputs. Then I got into the cluster again by burying a backdoor into an application dependency. Falco alerted Ozzie to my suspicious activity, but he used OpenVex to more quickly find the dependency that was exploitable specifically in his environment. So to prevent it from happening again, Ozzie now has a requirement that all SBOMs must have an associated source policy. So if one gets added or changed, this is for SBOM, sorry, that all, Ozzie added SBOM policy for this. And so it now has a requirement that all SBOMs must have an associated policy, so if one gets added or changed, Ozzie will know. And then we have Salsa source attestations. So because of me, Big Corp now requires Salsa source attestations for their third-party dependencies. The thing about this is that companies might have thousands of these dependencies, so that's where VSAs come in. So VSAs give you a machine-readable way to help ensure that the open source contributions follow secure practices like code review and authorship.
Looking back on it, I feel kind of embarrassed, and I thought I was good. But to be fair, I didn't know what, like 25 minutes ago that I do now, right? So I finally understand what they mean by onion layer security. It's about having strengths in depth and having lots of layers around your security to prevent lots of different attacks. Wow, all this great work made me quite hungry. I'll go microwave a burrito.
Thank you. Do you want to introduce yourself? Where are you?
I think she did.
Oh, okay. That's Puja, and I'm Whitney. Thank you. Oh, and a shout out to my friend Lewis, who helped me write a past version of this talk about Kubernetes security. Thank you.
Thank you.